And welcome. Here is another example of working on the difference of two sample means, calculating some probabilities. So let's take a look at this one. The mean score for freshmen on an aptitude test at a certain college is 580, with a standard deviation of 45. Assume the means to be measured to any degree of accuracy. Nice. Okay, so we don't need to make any sort of continuity correction here. What is the probability that two groups selected at random, one consisting of 44, another of 45 students, will differ in their mean scores by an amount between 3 and 8 points? By an amount between 3 and 8 points. All right. So I always like to start by reminding myself the needed parameters for a distribution of difference of sample means. This follows a normal distribution with the mean is the difference of the population means mu1 minus mu2. And remember that the variance of our difference here, our variance is sigma 1 squared over n1 plus sigma 2 squared over n2. So what do we have in this problem? There's some interesting aspects of this question. One is that the mean score, let's first sample 1 here and sample 2. Sample 1 and sample 2. Sample 1 and sample 2. The mean score is 580. The mean score is 580. It looks like, based on the way this question reads, is that those apply to both samples. But sample 1 only has 44 students. Two groups selected at random. Sample 1 has 44. Sample 2 has 45 students. And they have the same means. Mean 1, they're coming from the same college, but they are two different groups. So 580 and mu2 is 580 as well. That would mean sigma 1 here. We're given a standard deviation of 45. So the variance of group 1 will be 45 squared. So what is this? 45 squared. 2025. That is 2025. And this is the same variance that we're going to have for sample 2. For the 45 students, we'll have a variance of 2025 in our sample. Okay. So the means to be measured with any degree of accuracy. So the question reads, what's the probability that the two groups have mean scores that differ by an amount between 3 and 8 points? That differ by an amount between 3 and 8 points. Between 3 and 8 points, okay? So I think there's one detail that is easily overlooked here, all right? Let's take a look at what I think most will not overlook. If I take sample 1 and sample 2, like I have here, differing by an amount between 3 and 8 points, we'd be looking at the, so let me write this as follows. So let's see, we're talking about differ between 3 and 8 points. Differing between 3 and 8 points. So that would be something like this. That would be x1 bar minus x2 bar between 3 and 8. So I would be looking at 3 and 8. Between 3 and 8, right there. There's between 3 and 8, okay? Right? But here's what I think is something you gotta be careful for. This could go either way. It doesn't say anything about sample 1 being larger than sample 2. So you could also have x2 bar minus x1 bar be between 3 and 8. Being between 3 and 8. Okay? Right? This could go both ways. Now, what's nice about this is we can do this in sort of one nice swoop and just look at x1 bar minus x2 bar, not look at the other mean, although there's nothing wrong with doing these two questions sort of separately and then adding your results together. But what I want to mention here is to take this inequality right here, compound inequality, and think about what if you multiply everything by -1? What if we multiply everything by -1 here? If we multiply everything by -1, we're going to first change the ordering around. Here we're going to have x1 bar minus x2 bar. That multiplied by a -1 there, right? That's being multiplied by a -1, okay? And then you're going to be changing your bounds, -3 and -8. But remember, when you're working with inequalities and you multiply by -1, you reverse the direction of the inequality. You reverse the direction of the inequality here. You reverse the direction of the inequality. And so what we end up with is this is equivalent to this inequality right here, which is definitely written a little backwards. That's a little weird to read like that. So we'll write this as follows. All right, we're going to have -8, which is less than x1 bar minus x2 bar, which is less than -3, right? You think about -8 on a number line, that is smaller than -3, so we'll write that left to right. So what does it mean for these scores, these sample means, to differ between 3 and 8 points? We can either have this scenario or this scenario. All right, but remember that we're talking about something that is following a normal distribution. We're talking about something that is following a normal distribution, okay? Following a normal distribution. And so thinking about what this would mean symmetrically in terms of our normal distribution, if this is our mean, right? And we want to be between 3 and 8 from our mean, so maybe that's like, here's 3 and here's 8, or between -8 and -3. -8 and -3, right? By symmetry, because we're talking about a normal distribution here, these are the same areas, just on opposite directions or opposite sides of our normal curve. And so I'm going to write that down and notate that by symmetry, the probability that x1 bar minus x2 bar is less than 8, this is equal to the probability x1 bar minus x2 bar being less than or equal to -3. This is equal. So to get the desired probability then, the probability that they differ between 3 and 8 points, since they are the same, we can just compute one of these, take your choice, I'll pick the first one and double it. This is twice then the probability that 3 is less than x1 bar minus x2 bar is less than 8. It's twice that probability. It's twice that probability, okay? And if it's not obvious here, or not clear here, that these areas are symmetric, it would be at a later stage when you start substituting in your values here for the mean and the variance and start converting towards a standard normal problem, you'd start to see symmetric values at that point, okay? So what do we need to work on then? Right now is I am looking at computing this probability right here, then we're going to double it. We are going to double that. Okay, so what do we need to know here? What do I need to know? So I need my parameters of my normal distribution. I need my parameters of my normal distribution. So what is mu1 minus mu2? Well, that's the same. Those are the same values, so that's 0. And then what is the variance going to be here? What is sigma 1 squared over n1 plus sigma 2 squared over n2? So this is going to be 2025 over 44 plus 2025 over 45. And that is approximately equal to what? So let's do this in the calculator. 2025 divided by 44 plus 2025 divided by 45 here. So that variance is approximately 91.0227. 91.0227. All right. So the probability, then let's start converting this here. We're going to have 3 minus our mean, which is 0, divided by the square root of 91.0227. That'll be less than a standard normal random variable which is less than 8 minus the mean divided by the standard deviation, which in this case is the square root of 91.0227 yet again. And obviously there's going to be a little bit of round off error here with that standard deviation because this is getting cut off to 4 places. It's not exact. Certainly when we take the square root of that, it will not be exact either. So let's see what we have here. 3 over the square root of that. So what is the square root of 91.0227 here? That is about 9.54. So 3 divided by that. 3 divided by 9.54 is, what do I have? 0.314 if I round that off. So this is, because we're going to be looking up at a normal table, I'll round to the nearest value here, 0.31. It's less than z is less than, what is 8 divided by the square root of 91.0227, about 0.943. Hold on, I think I made a typo on my calculator. Should be 8 divided by 0.91, not 9. 8 divided by square root of 0.91027 is 0.8385, so I'll round that to 0.84. All right, there we go. Looks good, looks good. And so now we just need, we're going to look for this probability here, which we can do in the normal tables. So continuing to answer this question then, this is equivalent to twice the probability that we have a standard normal random variable that is between 0.31 and 0.84. 0.31 and 0.84. And again, at this point, this type of computation should be pretty routine. And I've got this rounded off 4 places, 0.3556. 0.3556. And that is how we would tackle a question like this. When it's vague, well, it's not really vague, but it's just not as specific as some of the examples we've seen maybe so far, right? The scores differ by between 3 and 8 points, and they could differ in either way. So be careful for that. A lot of people will forget that doubling factor and just take this first approach here, ignoring that this is also satisfied in the problem condition as well.